Good morning, my dear student. Today we are going to discuss about conjunction control. This is also one of the major topic in networking layer. Conjunction means at a common junction. A common junction. So, in a common junction, when two packets are meet, it should not be going to be crash. When it is going to be crash, that is called collision. So we are going to discuss about now what is mean by a conjunction. So at particular junction, how we are going to take a preventive measure to the packet should not be collide with the other packet during the transmission over the network layer. So how and what is the procedure we are going to learn about now conjunction control. Now guys, just have a look what is meant by conjunction control. So in this conjunction control we try to avoid the traffic. We try to avoid the traffic conjunctions. Then what is meant by traffic? So just here you can notice this here one diagram I have drawn over here. This is a traffic descriptor. Okay, traffic descriptor. So what is meant by traffic descriptor? So here the traffic descriptor is nothing but a maximum number of packets are transmitted over the network, then that is we call it as a data rate. So different types of packets we are transmitting during the transmission over the network. All the packets which are transmitted from the different sources to the different destination, it will be we call it as a traffic. So we have to draw the diagram between traffic descriptor. For that we have to take data rate versus seconds. So what is this data rate versus seconds? Why we are taking data rate versus seconds? See, a number of packet is transmitted over the network, we call it as data rate, right? So here you can notice this diagram. So here this is the time duration, and this one is the packet duration. Here you can see this when a graph is moving like this. When a graph is moving exponentially increases, and after that at maximum peak and exponentially decreases. Now we can take this graph into two parts. So here the two dotted lines I have drawn over here on the graph. So the two dotted lines which is differentiated, that the first dotted line is differentiated average data rate, or nothing but the amount of data which is transmitted over a time. The average data which is transmitted over a time is called average data rate. So peak data rate, this one is a peak data rate. Here the peak data rate is nothing but maximum rate of information is transmitted over a peak time. Okay, that is we call it as traffic. So this maximum peak we call it as a maximum burst size. So what is this maximum burst size? The maximum burst size is nothing but maximum length of the time the traffic is generated at peak rate. Maximum length of time the traffic is generated at a peak rate, right? Now we are going to discuss about or not, and also here one more thing we have to take a notice is effective bandwidth. So what is mean by bandwidth that networks need to allocate for a traffic flow. If suppose the bandwidth is very less, if suppose the bandwidth is very less, but the number of packets which is transmitted from source to destination is increasing a lot. Now the allocated bandwidth is very less, but the distribution of packets is very high. So now what will happen? The network traffic is going to be happen. So best example is take one road. So if a road on road we it is only having 2 to 3 vehicles at a time, it will be moving on a road on side by side. For example, on a single road, number of vehicles which is traveled on the road is for example 50. So 50 vehicles if it is moving at a time over the road is okay, it will be feasible. Okay, but instead of that 50, 300 or 400 vehicles are moving at a time over the road, it creates a traffic. So like this, here the vehicles are nothing but packets. So the path the road is nothing but network channel or network, right? So like this, when the bulk of amount of packets are transmitting at a single point of time, so automatically the packets may are going to be affect with a collision or nothing but accident to each other. So how we are going to eliminate this collision, what type of preventive measures we are going to take now? So for that, just have a look here. Conjunction is nothing but it may occurs if the load on the network is greater than the capacity of the network. It occurs due to queue in router and switches. See, same thing I told you now. The load, see, it may occur if the load on the network is greater than the capacity of the network. So I told you load is nothing but a number of packets. So capacity of the network means the size of the road. So the number of vehicles are more if the size of the road was less. So automatically what will happen? Automatically conjunction or traffic will going to be happen, because number of vehicles will be passed by over a queue. So the queue is nothing but a router and switches. So in networking concepts we are using routers and switches, so the packets are transmitting over routers and switches. We'll go for the next slide. See, in this conjunction control, just have a look here. Conjunction is equal to load greater than capacity. Just have a look here. Greater than capacity. What is mean by a load? Load is nothing but the number of packets sent over the network. Capacity is nothing but the number of packets a network can handle. This is so here the capacity more than a load. So means here you can see the below diagram. Here is the sender and here is the receiver. Sender will send the information, the receiver will receive the information. Now you can verify. So here sender having more than 4 packets at a time they are sending, but the receiver only receive 4 packets. So if the sender is sending more than 4 packets, what will happen? All the packets should be in a queue. So automatically what will happen? Conjunction will happen. See this diagram, then you will came to know that what is mean by conjunction control. So I will show you the diagram. Just have a look. See, just a minute. See, this is the sender having how many packets? 1 2 3 4 5 6 7. So here the receiver having 4 packets. So a sender is sending the information, 4 packets it is received. Other than the 4 packets, what will be the sender is sending more than 4 packets, then 4 packets, other than 4 packets, the remaining all packets should in a queue. See, it is waiting for the queue of the receiver. So it should ready to enter into the receiver, but it should be there is no free space to enter over here. So now what will happen? So these all these remaining packets are in an ideal state. So now what will happen? All should be all should be axed into each other in this. This is called conjunction. This is called conjunction. So how we are going to avoid this conjunction? We'll discuss now. Just a minute. See how we are going to divide this conjunction. See, we have to find out the performance. So what is meant by performance? So here we have to find out the network performance. So first we will draw a diagram for load and throughput. What is meant by load and what is meant by throughput? So and also traffic profile. So I will discuss now first load. So what is meant by load? So we have to draw the graph between load versus delay. Load versus delay. So load versus delay. For example, this is a network. It is having a capacity. So it capacity is the dotted lines. It is showing that the capacity of the network. The capacity means, so how much load it can bear. That is called capacity of the network. So now you can see this here, the graph is going to be exponentially increases and it meets the capacity over the capacity. It is passed over the graph. So below this dotted lines which are present, that is called conjunction free area, means there is no traffic is going to be present. If the load versus delay, so below the capacity means the conjunction is not happen, means there is no collision is going to be happen. There is no waiting state of packets over the network. But after this capacity which are present the frames, that is this place is nothing but conjunction area, means the probability of conjunction or probability of collision is going to be increased here mostly. Now you can see the delay as a function of load. The delay is the function of the load here. Now just go through this throughput. So what is mean by throughput? Throughput as a function of load. Throughput also as a function of node. And also the throughput is nothing but a number of packets passing per unit time. Throughput is nothing but the number of packets passing per unit time, that is we call it as throughput. So now you can see this. So we are going to draw the diagram between load versus throughput. Now you can see the diagram in throughput. So the graph is exponentially increases over the capacity. After that the graph is exponentially decreasing. This graph is showing that below the capacity line which are present, that is called conjunction free area. After the capacity of the line, that which is showing that this is a conjunction area, that is called conjunction area. Now we are going for next one is traffic profile. So now we are going to see what is this traffic profile. See here the traffic profile. Here I will going to draw a diagram between data rate versus time. First of all, I will take one is a rectangular box, that is called constant bitrate. means there is no change in data rate. So every time the constant bit rate is going to be maintained, means the same speed of data or data rate is same speed, means the number of data per second is transmitted is constant. The number of bits transmitted over a time, a particular time, is constant. That is called constant bit rate, because there is no change in bit rate over a different time interval, right? So next one is variable bit rate. Variable bit rate means data flow is changing with respect to of time. See this graph. This graph is representing variable bit rate. Variable bit rate means the data flow change with respect to of time. When a time was changed, the data bit rate also going to be changed. Next one is the burst data. What is mean by burst data? So here the burst data is data rate change suddenly. Here data rate changes suddenly, means sometimes the data is high, data is transmitted over the time, sometimes very low data is going to be transmitted. Means here you can notice that three cases we are going to be noticed. One is constant bit rate, and next one is variable bit rate, and next one is burst data rate. So if these three scenarios are present in a over the network, means automatically the conjunction is going to be appear, or nothing but the traffic should be high, because we don't predict that when the variable data rate will going to be appear, when the burst data rate is going to be appear. For example, we are at a network level of constant bit rate. Now we are transmitting the information over the network is constant. So suddenly some burst data rate we should some system is transmitted a burst data rate. Automatically over the network, number of packets is transmitted abruptly increases. Now the abruptly increases the packets over the network during transmission from source to destiny. Automatically when the constant bitrate packets also going to be move in a same network, so automatically what will happen, the speed difference between constant bitrate packets and burst data rate bitrate packets are different. So the burst data rate packets moving very faster. So if they are moving very faster, means it is automatically they collide with the other constant bitrate packets. So automatically conjunction is going to be happen. So how we are going to avoid these situations, we are going to learn now. See, conjunction controls are going to be categorized in two categories. One is open loop category, another one is closed loop category. So open loop category, it is always going to be used prevention, and closed loop category, it is always going for removal. So the open loop category prevention, what will be happen here, you can see this. First one is retransmission policy. Now here you can see this, what is mean by retransmission policy. A good retransmission policy here needed to be use TCP, transmission control packet. Now you can see this, here is a S and R, this is the source and receiver. So first of all I have transmitted a packet from source to receiver. So whether it is reached or not, I will wait for certain time. If I am not receive any acknowledgement, so automatically again I need to retransmit my packet from source to destiny. So unless it will wait certain time. So this is called retransmission policy. Now next one is window policy. So here the window policy is nothing but, here in window policy, the selective repeat go back window policy will be present. The go back window policy is, if the 5 frame packets are sended to the receiver, in that fifth packet was lost, For example, fifth packet was lost. Now go back and window protocol used to transmit all the packet once again to the receiver. This problem is present in go back and wait protocol. Go back and wait protocol, this problem will be present. So again you are retransmitting the 5 frames is again it is also going to be appear a conjunction, right? So how we are going to eliminate this problem in window policy is we need to take a selective ARQ is a better method. Selective ARQ, acknowledgement received, is going to be better. Here what will happen, whatever the packet was lost, that packet only be retransmitted by taking the selective repeat ARQ, right? Next one is acknowledgement policy. Acknowledgement policy, what is mean by acknowledgement policy? So here in acknowledgement policy, the source to the receiver, first I send the packet and wait for the acknowledgement. Once I receive the acknowledgement, once the receiver is received from the acknowledgement, then I need to retransmit, I need to send the next packet. So this is the acknowledgement policy. Means here every individual packet it is going to be wait for the acknowledgement. Until unless receive the acknowledgement only the next packet is transmitted. So this procedure will be present in a acknowledgement policy. But during this transmission from source to receiver, packet is transmitted, acknowledgement is received. So while we receiving the acknowledgements also, a number of packets is transmitted, that many number of acknowledgements are received, means automatically collision may occur, right? Collision may occur or conjunction also going to be appear. So what we have to do is the receiver will send an acknowledgement after a time on a n packets. By this we can reduce the traffic. So the acknowledgement policy, we send the n number of packets, we should wait for a n number of we should wait for certain time, so we'll receive all the acknowledgements at a time. So this is called acknowledgement policy. So these all are the preventions measures. So next one is discarding the policy. What is meant by discarding policy? The discarding policy is nothing but discarding the less sensitive packets from the network. So the packets which is not required from source to destiny, we have to discard that sensitive packets because of avoiding or prevention of conjunction. Next one is admission policy. What is meant by admission policy? So it is worked on a quality of service mechanism, quality of QSM, quality of service mechanism. In this switches will be checked. In this switches will be checked the flow of resource requirement before admit to the network. Means here admission policy, it will going to check every switches and routers will check whether the received packet strength is compatible or it is having such occupancy or nothing but that much of circuit network we are having or not before going to transmit that information over the network itself. They are going to self-checked, the resource self-checked by the admission policy. If the resources are not available or not suited to the information packet transmission over the network, means then and there itself they discard the information. So that's this is one of the preventive measure for open loop conjunction control. Now we'll go for the closed loop conjunction control. What is this closed loop conjunction control? So here closed loop conjunction control means the removal process will be present. This is also one of the removal technique. What is this removal technique? sorry, before admission policy, one of the example also present. That example is, for example, 20 frames will be send source to destination. First, admission policy will check the sufficient amount of infrastructure, whether it will be present or not. If the sufficient infrastructure is not present, the frames will be discarded. This is the policy will be present in admission policy example. Next we'll go for the closed loop. So in closed loops are nothing but the removal technique. So the removal techniques, what are the first technique is back pressure. What is this back pressure? Now you can see this here. S is the source, and here D, last one D is a destination. Over the source to destination, here N1, N2, N3, N4 are the networks. N1, N2, N3, N4 are the networks. Now here the green arrows are indicating that the data flow from source to destination. From source to destination, it represents the data flow. Here suppose from here there N3, here in N3 network, the conjunction node was appear. So collision may appear, for example, at a N3. Now what will happen? So the back pressure here, the reverse direction, the red color arrows are noting to source direction, means that arrows are indicating that at N3 level conjunction was happened. So it will gives a back pressure to the source by indicating the arrow lines. That indicating arrow lines, we call it as a back pressure. So the source will understand at N3 node I received a collision, so I need to stop the transmission. So like this also we can avoid the conjunction or finding the conjunction where will happen. And next one is choke packet. This is also one of the important, the choke packet. So you should know the difference between back pressure and choke packet. The little difference will be present in back pressure and choke packet. Here the choke packet, same diagram I need to use. Here also source to destination, the information is passing by indicating the green lines over the diagram. Here this is the data is transmitted from source to destination, but here N3 packet at N3 network, the conjunction was happened. Now what we'll do here is from N3 to directly source some choke packet will be transmitted from N3 to source directly. Some choke packet will be transmitted. So by receiving the choke packet by the from the N3 of the source, now the source will decided that okay, I have a collision during my packets are collided at N3 network, N3 router, so I need to stop my transmission. So this is a choke packet. Now we will go for the one more technique is implicit signaling. So implicit signaling is nothing but here no communication between conjunction node. There is no communication between conjunction node with other nodes or source. The source assumes that conjunction is occurred. When the source will understand the conjunction will occur, whether the acknowledgement was not received by the destination or delay in the acknowledgement from the source to destination or destination to source, the acknowledgement time was delayed. So automatically the source will understand. This procedure is called implicit signaling. So next one is explicit signaling. What is mean by explicit signaling? So explicit signaling is nothing but conjuncted or congested node send a signal to the source to destination signal is included the data packet. So here the packet is divided into backward and forward. Backward means node to source and forwarded means node to destination. Same here like choke packet you can verify whether explicit signaling is the packet which is where the crash will occur, where the collision will occur. So from there onwards to the information is sent to the source, that is called node to source is nothing but backward signaling, or whether node to destination is called forward signaling. So forward signaling, this procedure is called explicit signaling. These all are the removal, or closed loop is nothing but the removal of conjunction control. So we have discussed now about prevention of conjunction control and the removal of conjunction controls also. This is the one of the most important topic over the network channel. So when we are going to focus on this conjunction control categories, this is very useful to understand what is the network and how we are going to avoid the traffic and how we are going to regulate the traffic over the packet during the transmission over the network. So okay, we'll going to discuss about in next classes about quality of service, and until this is the conclusion of your third unit. Thank you.